Welcome to another edition of Mr. Weis Solves an Old AP Problem. Today we're working on the 2013 number 3 calculus BC exam. We have one of these problems where we're given a chart of values for some function, usually that represents something in the real world. In this case, hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t, for t from 0 through 6, is given by a differentiable function c, where t is measured in minutes and c is measured in ounces. So c is some function, it's continuous, we don't know all of its values, but we do know that, for example, at time 0 there's no coffee. After 1 minute there's 5.3 ounces of coffee in the cup, and so on. Okay? So that's the setup for the problem. Part A says to use the data to approximate the derivative of c at 3.5. So this is fairly straightforward. We've done these a bunch of times. C of 3.5 is approximately, so this is the slope of the tangent line to c at 3.5. We don't know what c, we can't graph c, we only know these points. So I think since 3.5 is between 3 and 4, I would estimate that the slope of the tangent line at 3.5 is equal to the slope of the secant line going from time 3 to time 4. So that is c of 4 minus c of 3 over 4 minus 3. So in this case that is 12.8 minus 11.2 over 1, which I believe is, what's that, 1.6? That makes sense, 1.6. Now we want to use proper units here. This is a derivative, it's the rate of change of c with respect to t, so it's ounces per minute. And that's my final answer. Okay, here we are with part B of the 2013 number 3, dealing with this function, a differentiable function c that tells us the amount of coffee at any moment of time between time 0 and time 6 minutes in this coffee cup. Part 2 says, is there a time t where c prime of t equals 2? Okay, the answer is yes, and here's how we know. Similar to what we did right here where we found the slope of the tangent line, we estimated the slope of the tangent line as 3.5. I'm going to look for a secant line that has a slope of 2. If I can find a secant line that has a slope of 2, then we're going to be set. And in fact, I can see one right here. Look at the secant line from time 4 to time 2. C of 4 minus C of 2 over 4 minus 2 is going to be 12.8 minus 8.8 all over 2, but 12.8 minus 8.8 is 4 over 2, which is 2. Thus, because we're told that c is a differentiable and thus continuous function, by the mean value theorem, there must exist a point t between time 2 and time 4, where the slope of the tangent line to c, in other words c prime, equals 2. By the mean value theorem, since c is differentiable and continuous, there is a t in between 2 and 4 such that c prime of t equals 2. And that's my answer for part B. Okay, here we are with part C of the 2013 AP Calculus BC exam number 3. In this part we're asked to estimate the integral from 0 to 6 of this function c of t divided by 6. So 1/6 of this integral. That should look somewhat familiar because after we're done estimating this, we're supposed to say what it means. They want us to use 3 rectangles with the midpoints. So this is pretty straightforward. We've got exactly the data we need. So 1/6 times the integral from 0 to 6 of c of t dt is going to equal 1/6. Okay, so we're going to do each of our rectangles. So the width of our first rectangle is 2 because we're going to go from 0 to 2. That's the width. And the height of our first rectangle is c of 1. C of 1, which happens to be 5.3. Plus. And we go to our second rectangle. Our second rectangle goes from 2 to 4. So again, the width of that rectangle is 2. This happens to be a regular partition. And the height of that rectangle is c of 3, which happens to be 11.2. Plus our third rectangle is the one that goes from 4 to 6, which again has a width of 2. This time it has a height of c of 5, which happens to be 13.8. So I'm going to get out my calculator and I'm going to quickly try to estimate all of this. So I have 1 divided by 6 times the quantity, 5.3 times 2, plus 11.2 times 2, plus 13.8 times 2. And this comes out to be 10.1. One thing I'd like to fix, this isn't equals, this is approximately. This is approximately 10.1. And now they do ask us to estimate what this ends up being, and what unit this is in, and all of that stuff. So one way of thinking about this is we're finding. So a good way of thinking about what this actually ends up being here is when we're finding this area. Note that the area is y values times x values. The y values are ounces, and the x values are time. So this thing right here is in ounces times time. Now we're dividing by 6, that's because we're doing it over the interval from 0 to 6, which is a time unit. So this is ounces times time divided by time, meaning that this is ultimately in ounces. Now that's one way of thinking about what unit this is in, but the other way of thinking about it is because this should look familiar. This is actually known as this is the formula for the average value of the function. I believe in our book we call this c sub average. This is the average value of c over the interval in question. So in other words, over these 6 minutes of time as the coffee is filling up, one could ask, how much coffee is in this coffee cup on average? And the answer is 10.1 ounces. And that is my final answer. Okay, so here we are in the final part of the 2013 AP Calculus BC exam number 3. This one, we abandoned the function that was telling us the amount of coffee that was in the cup at any moment in time and say, actually, we have a full model of this and it's actually B of t. B of t is the amount of coffee that's in the cup at time t. You can see that when you plug in t equals 0, for example, you do in fact get 0, which makes a lot of sense. And they're asking for us the instantaneous rate of change of the coffee in the coffee cup at time 5 minutes. In other words, they're asking us for b prime of 5. So this is a straightforward problem. B prime of t is what we calculate first. I should note actually that this is in the beginning of the AP exam, so you even have a calculator for this. This is really straightforward. I'm going to actually do it by hand, because why not? The derivative of 16 is 0. The derivative of negative 16e to the negative 0.4t would be negative 16e to the negative 0.4t times, by the chain rule, the derivative of the to the, which is negative 0.4. So when all the smoke clears, the negatives end up canceling, and we should get, let's see, 16, this is 4/10 or 2/5. So this would be 32/5 e to the negative 0.4t. I can now plug in 5 into this. So b prime of 5, which is what they're asking me for, will end up equaling 32/5 times e to the negative, let's see, so this is 2/5 times 5, 2/5 times 5, so e to the negative 2, so this is 32 over 5e squared. And the unit for this would be in ounces per minute. It's an instantaneous rate of change, and that's my final answer.